Okay, now that we understand the difference between the direct variation and the inverse variation, now we can start actually combining those together, because there are times when a problem may have certain variables that are directly related mixed in with variables that are also inversely related. And this example that we have up here is actually a really good illustration of that. Again, when it's combined, you've got a combination of direct and inverse. So if we took advertising of a company versus its monthly sales, that has a direct relationship. So if S represents my sales, and it's the sales, and then the A is the advertising, if it has a direct relationship, if I advertise more, I'm probably going to sell more. Versus if I'm not advertising, people don't know I'm there and I can't sell anything. So that has a direct relationship. If you're going to put the money towards advertising, you're going to draw people in and they're probably going to buy your product. Okay? Well, when we have something like this, if we have a company that's advertising their stuff and they're selling it, well, there's also another variable, and that's the price of the product. The company has to buy the product so that they can in turn sell it. Well, the price of the product and the sales has an inverse relationship, because if I have to spend more to buy my product, I have to charge more, and if my prices are going up, my sales are probably going to go down. But as long as the money that I'm buying my product at stays low, then I can keep my prices low, which means, more people are going to buy it, so my sales will go up. So you've got three things here. You've got how much I'm advertising, how much I'm putting towards my advertising, how much I'm selling, and how much I have to pay and buy the product for, which affects how much I have to charge. So all of these go together. So my monthly sales is directly related to my advertising, because they have a direct relationship. If advertising goes up, sales goes up. If advertising goes down, sales go down. But also at the same time, sales has an inverse relationship to the price. Okay, so all of this going together, you've got some of the variables are directly related, some of them are inverse. And we can put these together, and basically if you have the inverse part, anything that's inverse related goes in the denominator, because inverse is division. Notice too, the K is still there. The K will always be there. Okay, so let's look at an example. Again, ours is not as specific as that one. Again, just kind of very generic of you've got just X's, Y's, and Z's. We don't know what these numbers represent. But the same steps are going to apply, which is we have to set up the equation first. So that's going to come from the first sentence. They're giving me everything that I need to set this up. So again, I'm looking at keywords. And again, I can't start at the end of the sentence and put all this together. It's just like a puzzle. It's one piece at a time. So the very first thing that I see is Y varies directly as X. Right there, I'm going to write that out. Y varies directly as X. Okay? And then we have this word and. So now we know something's going to happen behind this. And it says and inversely. When I see inverse variation or inversely, I know I divide because it's K divided by X. Whatever is behind your word inverse goes in your denominator. And they're telling me that it's the square of Z. Now, do pay close attention, because a lot of people try to put a square root there. It doesn't say square root, it just says square. So pay really close attention to that. Again, that's going to be the hardest part of these problems, is getting it set up, because if you don't have it correct, there's no way you'll get the right answer, because you're going to be plugging in numbers to a wrong equation. So that's the most important part. So we've got it set up. Now it's just a matter of plugging in the numbers. So in sentence 2, they tell me Y is 20. They tell me X is 50. And they tell me Z is 5. And don't forget that that 5 is also squared. So do pay attention to that. Of course, here we get 20 equals 50K over 25 in my denominator, which gives me 20 equals 2K. Dividing both sides by 2, I get my K, which is 10. And we take that K, we plug it right back into what it's equal to. So we have Y equals 10X over Z squared. And once we have our k, again, these work all the same way as they did in the first part of this section with just the direct variation and inverse variation by itself. Now they're going to tell me what to plug in. So now they're telling me x is 3, so it's going to be 10 times 3. Z is 6, but don't forget the z is also squared. So we end up with y equals 30 over 36. Of course, that doesn't divide evenly. Don't give me a decimal. We reduce our fraction to 5 over 6. That's the exact answer. We don't want to give a rounded decimal answer because that's just an approximation. We always want to give the exact answer, which is 5 over 6. Okay, here's another one. Again, very similar, just slightly different scenario. This time, when we go to set these problems up, we have y varies jointly. Now, remember that jointly is still direct variation. I'm still going to be multiplying. So we have y varies jointly, or direct, as a and b. So instead of just y equals ka, we have ka and the b. Okay? And, so that's where it breaks apart. Inversely. Anytime we see the word inversely, we know we're dividing. And this time, what I mentioned on the previous example is pay attention to the power of c. This time, it doesn't just say square of c, it says square root. So I have to square root the c. Again, that's the most vital part. Once we have that, now we're just ready to plug in the numbers they give me in the second sentence. Y is 12. They give me a is 3, b is 2, and c is 25. That gives me 12 equals 6k over 5. A couple different ways we can do that. If we just start by multiplying both sides by 5 to move the 5 over, that's going to give me, and you can multiply by the reciprocal here. You can multiply both sides by 5 over 6, but I'm just going to do one step at a time. Which dividing both sides by 6 gives me a constant, again, like the last problem, came out with a constant of 10. That's going to take me back up to the beginning, where I will now plug that in. So we've got 10ab over the square root of c. So now we're ready for the final problem, which is now they tell me a is 5, so I have 10 times a, which is 5, times b, which they give me as 3, over the square root of c, which they give me as 9. This is going to give me an answer of 150. 10 times 5 is 50. 50 times 3 over 3, which gives me an answer of 50. Okay, so pay attention again to the wording. Next couple examples we'll do are going to be a little bit more generic, even more generic than what we just did, where we're not going to be given any numbers. Again, we basically just want to practice setting these problems up in different scenarios. So, starting at the beginning, they just asked me to write an equation that expresses this relationship. So we'll start there. Again, looking for my keyword, varies directly. I know I'm going to be multiplying here. So it's x is what varies directly as cube root of z. So that's a little bit different. It's not the cube of z, it's the cube root of z. And inversely. Inversely, whatever's behind that means we divide, it goes down into the denominator, and it's just inversely as just y. Okay, so these are kind of, again, this is a two-part problem because they asked me to write the equation, which I've done. If I miss that, part B is going to be wrong. The second part is going to be wrong because now they say solve it for y. So this is just a matter of solving an equation. We just don't have any numbers, which means if we're going to solve this for y, we got to get that y by itself. Since it's in the denominator, first step is going to be I got to get this y out of the denominator because I've got to get it by itself anyways. So since all of this is being divided by y, the opposite of dividing by y is multiplying by y. when I do that, of course, the y that we multiply by cancels out the y of the denominator. I'm left with yx, or preferably, when you have double variables, I prefer that you put it in alphabetical order. So xy equals k times the cube root of z. And since I got to get this y by itself, the only thing I got to do is move that x. Since it's being multiplied, we do the opposite, which is divide. So my x's cancel, and I'm able to get the y by itself, and it's equal to k times the cube root of z divided by x. Okay, so you kind of have these, depending on the way it's worded, two parts to this. The equation was the first part. You had to set it up, which was right here, and then we had to solve. Okay, for part B of the same example, same directions. We're going to set it up, and then we're going to solve it for one of the variables. Again, biggest thing is paying attention to your keywords and knowing what they mean. X varies jointly, so x, that's direct, so it's going to be multiplication, as y and z. No square root, no cube root, no square, no exponent. It's just x varies jointly as y and z. And, oops, wrong and inversely. If it says inversely, that's where we divide, and whatever's behind that word inverse goes in my denominator. And it's a square root, not a square, but a square root of w. Now they asked me to solve this for w. So we set it up, that's one part, okay? And then we get that w by itself. And it's very similar to the last one because this w is in the denominator. It's first got to come out of the denominator because we can't solve for it when it's down there. So, since I'm dividing by square root w, I have to do the opposite, which is multiply both sides by the square root of w. Of course, the multiplication cancels out because we've taken it from the left, or from the right, moved it to the left. Now, the proper way to write this would be the x would go in front of the square root, equals k times y times z. And again, still trying to get this w by itself. Since there's an x there being multiplied, I'm going to move the x over to the other side. So divide both sides by x. So this x is canceled. And I've got the square root of w now by itself. However, it doesn't say solve for the square root of w. It says solve for w, which means I've got to get rid of the square root. Going back to our basics of how do we solve an equation, the opposite of a square root would be a square. If I square the left, I have to square the right, which means you got to square everything on the right. The square cancels out the square root, which does allow me to get my w by itself. And everything on this other side, you don't have to actually apply that square. You can just leave everything on the right side squared. Okay, so just again, kind of taking us back to our basics of this is how we solve an equation. We do the opposite, and we got to make sure that we do it on both sides. Alright, and the last one we have is a little bit more, or a little bit less generic. It's more specific to how you would actually see these variation problems used in more of a real-life type setting. So if we read through this, again, we're still just looking for our keywords. We have the distance, which they tell me to let be s. I'm actually going to change that because since it's distance, I'm going to use d. The distance that a body falls from rest varies directly as the square of the time. And they let time be t, so we'll keep that. Now, that's my first sentence. That's where I'm going to pull out my equation. Now, what we've had has been d varies directly as t, or x varies directly as y and z. Well, all we've done is put words in here. If I take the words out, and I say d varies directly as the square of t. If I just take out all the specific words, I can see it a little bit better. This is d varies directly as the square of t. and that's all I can pull out of that. The rest of this is just telling me, they're saying, well, d is distance, so the distance, and we're specifically talking about the distance that a body falls, varies directly as the square of t, and they're just telling me that time is t. So if you take out all the specific words and just look at the very generic part of this problem, it's still very basic and very pretty much point blank. You can pull out all the words. There's no hidden words or anything. It's all given to you. So distance equals k times t squared. That's sentence 1. Now, the second sentence tells me, or the first half of the second sentence, gives me some numbers to plug in. Well, if I know that d is distance and t is my time, they're telling me that if skydivers fall 64 feet, there's your distance. That's how far they fell. In 2 seconds, and that's your time. Time is 2. They're still saying d is 64 and t is 2. You just have to interpret that a little bit more. So we have 64 equals 4k. Dividing both sides by 4, I know that my constant is going to be 16. So no matter what, that's what my constant will be. K equals t. So distance is equal to 16 t squared. Alright, so we got our k. Now it's saying how far will they fall, which is what's the distance going to be. How far will they fall? What's the distance if my time goes up from 2 to 4.5? So plug in 4.5 for your time. And then here, of course, we do exponents first. And you should come out with an answer of 324. You want to do 4.5 squared first, which is 4.5 times itself, which will give you 20.25. Multiply that by 16, and that's how we come out with an answer of 324.